Today I want to talk a little bit about even and odd functions. A function is called an even function if the graph is symmetric about the y-axis. And we're familiar with a couple of these functions that are going to satisfy this. F of x equals x squared, our parent graph for the parabola, is an even function. You can see that it has symmetry about the y-axis. Also another one, g of x equals the absolute value of x, is an even function because there is symmetry around the y-axis. Now sometimes it's not convenient to make a graph and check for symmetry, so we'll talk about an algebraic way we can test for an even function. In addition to the graph being symmetrical across the y-axis, a function is said to be even if f of the opposite of x, so changing the sign of the input value, has to equal f of x. So what that is saying is changing the input value to the opposite doesn't affect the output value. You get the same thing. So let me kind of show you with this function for our parent graph for our parabola. If I evaluate f of 2, 2 squared is 4. If I evaluate f of negative 2, if I square a negative 2, I get 4. So changing the sign to the opposite did not affect f of x, the output. If I substitute a 1, 1 squared is 1. If I square a negative 1, I get 1. If I square a 5, I get 25. And if I change it to the opposite and square it, I still get 25. So that's what I mean when I say changing the input value to the opposite doesn't change the output value. Now the question is, or right over here it says, I have to do this for all values of x. I would have to show that it's even. So plugging in numbers is not good enough. It just can help you see it, but what you need to do is you have to think it through for all values of x. So for example, I'm going to think about what is f of the opposite of x. Well, what does that tell me to do? I'm going to replace the x in my function with the opposite. Now remember that doesn't mean it's negative. It doesn't mean it's a negative value. It's because maybe x was positive and the opposite is negative, or maybe my original x is negative and the opposite is positive. So it's the opposite. But regardless of whatever this is, whether this be a negative or positive number, if you square it, you're always going to get a positive. So it's going to be equivalent to x squared, which is f of x. So I have just shown for all values of x, if I substitute in the opposite, I just showed algebraically how I get f of x. And since those are equal, that makes it an even function. So that's how we test it algebraically. So let's talk about an odd function. A function is called an odd function if the graph is symmetric about the origin. And an example that you're familiar with, f of x equals x cubed. And I graphed it here. So remember, I scaled it by 2. I have 0, 0, 1, 1, 2, 8. If you cube a negative 1, you get negative 1. If you cube a negative 2, you get negative 8. Now, the rule for this, to test it algebraically, is if you change the input value to the opposite, then the output value also changes to the opposite. So let me show you with some numbers. If we evaluate 1 cubed, we get 1. If we take negative 1 cubed, we get the opposite. We get negative 1. If we cube a 2, we get 8. If we cube a negative 2, we get negative 8. If we cube a half times a half times a half is 1/8. And if we cube a negative a half times negative a half times negative a half, we get negative 1/8. So notice in every case, when I switched my x value to the opposite, my y value or my range value also switched to the opposite. That's how we can tell if it's an odd function. Now, keep in mind what I said before, you can't prove it with numbers. The way that you have to prove it is with a variable. So let me show you on this one. I'm going to figure out what f of negative x is. So I'm going to replace the x in my function with the opposite of x. I know I said negative. I slip into that. I should say the opposite. So think about what this means. It's the opposite of x times the opposite of x times the opposite of x. Well, I've got 3 negative signs there, so that's going to be equivalent to this. Well, also we see that negative f of x is x cubed, so we get this. So we have shown that this equals negative f of x, which makes it an odd function. Okay, so let me show you one that's not a parent graph. So let's determine whether this particular function, f of x equals 2x squared plus 1, we want to determine if it's even or if it's odd or neither, because it's possible to not have symmetry to either of those two positions. So what I'm going to start by doing is I'm going to evaluate f of the opposite of x. So remember what we do, we take this minus x and we substitute it in where the x is. So we're going to have this. Okay, so that's what I do first. Now, I'm squaring this opposite of x, so regardless of what this sign is, when I square it, it's going to be positive. So I could write this as 2x squared plus 1. So that's what I would do first. Now, I need to have something to compare. Actually, I can see right away. Look at what f of x is. So we have f of x written right here. So this is f of x. So actually, I can say this is an even function. So this is even. Let me just show you how you would test to see if this, as far as, well, no, I'll do that later. If it's even, it can't be odd. There's actually only one function that is both even and odd, and that is f of x equals 0, which is a horizontal line. It's the x-axis, and that is symmetric to in both ways. So that is actually the only function that is both even and odd. So now that I've shown this is even, it can't be odd. Okay, so let's do this one. Determine whether f of x equals x squared plus 3x minus 1 is even, odd, or neither. So I start by evaluating f of the opposite of x. So I'm going to replace the x with this. Sorry. Okay, and simplify. So I'm squaring, so it doesn't matter. It's going to change it to x squared. It's going to be positive. This right here, though, it's going to be a minus 3x, and then I have a minus 1. Well, clearly I can see, if I compare that to f of x, this is not equal to f of x. So right away I know this is not even. So in order to test if it's odd, we need to write down what negative, or the opposite of f of x is. So that's going to be, I'm going to replace f of x with this. So I'm taking the opposite of my original function. So I have to distribute the minus sign. And now what I want to compare is I want to compare this to, let me just show this. So I want to compare this value here to this value here. So I'm comparing f of this minus x to negative, or to the opposite of f of x. So if you notice that, they're not the same. So that means this is not odd, which makes it neither. But that's the algebra you have to go through to test it. So there's three things you're looking at. You're looking at f of x, f of minus x, or the opposite of x, and the opposite of f of x. You're looking at those three things, and then you're making some comparisons between them to see where the equalities are. So here's the last one. Determine whether f of x equals 2x plus 1 over x is even, odd, or neither. So we're going to need, well, we already have f of x. I'm going to find f of the opposite of x. And if I do that, I get, so replace the x with the opposite of x. And I'm multiplying here, so I get a negative 2x. And it doesn't matter where I put the negative sign, I'm just going to make this minus 1 over x. And then I'm going to go ahead and evaluate the opposite of f of x. So I'm just going to do all three right at once. So we see that's going to be the opposite of 2x plus 1 over x. Remember to distribute on the minus sign. So we get minus 2x, and that makes this a minus 1 over x. And then I compare. So take a look at it. F of x compared to f of the opposite of x. Those are not equal. So that tells me it's not even. So then I compare f of x. I compare f of the opposite of x to negative f of x. And notice they're equal. So that tells me that this is an odd function. You can check any of these out on a graph. I went ahead and graphed that. Here's what the function is. I just graphed this function. And take a look here. And you can kind of see one piece of it up here in quadrant 1 and one piece of it down here in quadrant 3. And if you took this piece here and rotated it 180 degrees around the origin, or actually if you took both pieces and just rotated this 180 degrees around the origin, you would actually have the same graph. That's what we just showed. So it shows the symmetry around the origin when you look at that. So that is how you determine even and odd functions. Oh, didn't want to do that. So that will help with some of your homework problems in this section.